Hey there, science fans! Welcome to another exciting journey into the world of technology. Ever wonder what makes your computer tick? What's behind the magic of your everyday digital experiences? It's all thanks to the CPU, or Central Processing Unit, the brain of your computer. This tiny powerhouse is the mastermind behind every operation. This tiny chip is responsible for executing instructions and running all the software you love. It's like having a super efficient manager inside your machine. From browsing the internet to playing video games, the CPU is the heart of it all. It ensures everything runs smoothly and efficiently. But how do you make something so small and powerful? The process is as intricate as it is fascinating. It's like building a city on a microchip. Imagine constructing skyscrapers and roads on a piece of silicon. It all starts with a special material called silicon. This element is the foundation of modern computing, enabling the creation of these incredible chips. Silicon is a semiconductor, which means it can conduct electricity under certain conditions. What's really cool is that we extract silicon from sand, which is super abundant on Earth. This purified silicon is then grown into a giant crystal, like a massive, shiny ice cube. This crystal is sliced into super thin wafers, kind of like cutting a loaf of bread. These wafers are the foundation for our microchips. Now, imagine you're creating a super detailed blueprint for a city, but instead of pen and paper, you're using light. That's photolithography. This process is essential in making the tiny circuits that power our modern devices, from smartphones to supercomputers. First, the silicon wafer is coated with a light-sensitive material called photoresist. This coating is crucial because it reacts to light, allowing us to create intricate patterns on the wafer's surface. Then, a mask with a specific circuit pattern is placed over it. This mask acts like a blueprint, guiding where the light will hit and where it won't. Think of the mask like a stencil. Just as a stencil helps you paint a specific design, the mask helps create precise circuit patterns on the wafer. When UV light shines through the mask, it hardens the exposed photoresist, leaving the unexposed parts soft. This selective hardening is what allows us to create detailed and complex circuit designs. These soft parts are then washed away, revealing the circuit pattern on the silicon wafer. This process is repeated multiple times to build up the layers of the circuit, ultimately creating the powerful chips that drive our technology. Section 4. Etching. Carving the circuit city. With the circuit pattern exposed, it's time to etch. Etching is like using tiny chisels to carve out the circuit design on the silicon wafer. This process removes the unwanted silicon, leaving behind the intricate pathways for electricity to flow. There are different etching methods, but they all achieve the same goal to create the physical structure of the circuits on the microchip. Section 5. Doping. Turning sand into superconductors. Now comes the magic. This is where the real transformation happens. Doping is like adding special ingredients to our silicon wafer to change its electrical properties. Think of it as seasoning a dish to enhance its flavor. By introducing tiny amounts of impurities, we can make specific areas of the silicon more or less conductive. These impurities are carefully selected to achieve the desired electrical characteristics. This precise control over conductivity is what allows us to create transistors, the building blocks of all modern electronics. Transistors are essential components in everything from smartphones to supercomputers. Transistors act like tiny switches, controlling the flow of electricity within the microchip. They enable complex computations and data processing by turning on and off at incredible speeds.